All right, we're going to get started today. Today we're going to look at molding toolpaths, or just creating a molding, either for a picture frame or just straight molding, whatever you want to have a molding toolpath for, or mold for. So molding, I'm not talking about making a mold for an item. We're making a wood profile shape. So we're going to get started here. I am using a spire, but everything that we're going to be going over today can be done in both Aspire and in VCarve Pro. It is a three-dimensional toolpath that is being created with the molding toolpath, but it's only the toolpath, and we're basically extruding a shape or a profile along a selected vector. So what I mean by molding toolpath is I've just downloaded a picture of some molding toolpath, something that you'd pick up at the lumber yard. Different shapes, different profiles. Take a look at how we could duplicate some of these shapes. And then we're also going to take a look at using a form tool to be able to create a basic shape as well, or a profiled shape by stacking up different form tools. Form tools meaning a profiling tool bit where it is going to look like what we have here. So that is going to be today's session. As always, for those that are new coming in, feel free to use the chat window to ask any questions as we move along. I will do my best to answer them as they come up. We also have folks that will be able to chat with you as well in that window. So please ask questions. Questions help everyone, and I even learn from the questions sometimes. So I'm going to jump right into it, and I have almost a fresh start of Aspire, just a few pictures imported and drawings done, but no toolpaths created yet. And that's what we're really going to be focusing on today, is just the toolpaths, not so much on the drawing, maybe a little bit in some bitmap tracing or raster image tracing. So the first thing we're going to do is just take a quick look and understanding of what a profile molding toolpath is. We'll come back and show you how I created this shape. But what we're going to first do is take this shape and extrude it along this line using the molding toolpath. Starting off, just selecting the profile or the extruded line, and then selecting the profile. Coming over to the molding toolpath, we get these lines here now that says that this is the direction that is going to get profiled along. So this is basically going to be extruded on the left side of this line. We'll come back and take a look at all of this in depth a little bit more, but I'm just going to quickly come down and select calculate to show what has happened here. We have just now created a profile shape of this. So it is going to follow along and kind of step over based on what our bit selection step over and follow the shape of our drawn profile along our selected vector. Sorry, that was kind of a complicated answer for saying this is going to take this shape and throw it along this line. So we can see that, just divide this up into two. And what we have here is the flat section down here is this section here. It kind of steps up and just follows along here. So we are able to create this profile shape, and we're going to extrude that shape over a length of any line or any sets of vectors. The offsetting, or the direction that the sweep or it goes, is all based on the starting point of the vector. The starting point is this green node right here, going into node editing. We could change that direction by right-clicking and selecting to change direction. When we're in the profile toolpath, we're going to reverse the direction. And what that is going to do is, rather than having the shorter side over here, it's going to put the larger side against that edge. So we're just going to simply calculate here, and we can see how it has like reversed that direction. I'm now curious if the start depth has, or start point has anything to do with what side of this line it goes on. So let's just try changing the start point from the top and setting that to the bottom. And to do that, I just went into Node Edit, hovered my mouse over top of that node and selected the letter P. And yeah, sure enough, there. So it is going to be offset to the left now. So that is what these lines are indicating. The direction of the path that's going to start. We can see that the arrow is starting from the green start point. So basically what is happening here is the green dots are kind of matching up to one another and extruding it along this line. So if we wanted to, say, create just a picture frame for this, of this profile, I'm going to close the 3D view there. And with this toolpath here, I'm just going to delete it and remove it. Don't need it. I'm going to now just draw out a rectangle. You can specify the size of the rectangle that you would like. Let's just go 5 by 5. And we'll center that within the job. Now doing the exact same thing as we did, rather than selecting the line, I'm going to select the square, then the profile, coming into the molding toolpath. And you see they are indicating which way they are going to be offset. So if I am following and understanding correctly what this start point means on this profile, that is, this side is going to be up against here. This lower section of the profile here is going to be extended out past over here. So let's just take a quick look to see if that is the case, and it is. We can see that the higher point is here and it flows outward. And just reset this and preview what we got. So it just kind of flows straight down, and it is, again, following the profile shape of what we have drawn. All right, so I'm going to close the, just maximize our 2D view here, back up, and I'm going to take a look at a few of the settings, a little bit more in depth of what is happening here. And to do that, I'm going to go back to the selection of just a single line, because that allows us to kind of get an end shot of what the toolpath is looking like. So far I've selected the vectors and then have come in and selected the profile toolpath. You don't have to do it in that order. The profiling toolpath does allow you to open it up, select both the objects, and create it that way. So the first thing that's happening here is we have the toolpath position. Right now, we're at 0 and 0, meaning that our job is set up as 3/4 inch material. And the height of our molding here must also be set at 3/4. So let's back up just once. I'm going to take this profile and reduce it by half. So I'm going to scale that down to 0.375 and select apply. Now undo that. I'm going to unlink the X and Y because I like the width of that. I just want to skew it a little bit in the height. So I'm going to go 375 and select apply. So we can see how I've just kind of basically changed the shape of that profile simply by changing the Y value. All right, so now we are 3/8 of an inch high. With that being known, it might make what's going to happen here hopefully understandable. So this lighter brown section here is the height, and it is the area of our material that the profile is going to be cut through. We could change that and bring that down or bring that up. Typically, you probably wanted to have it sit down in from the top of the material just a little bit. And once we preview what this two settings look like, where this sits, I'll come back to explain why you might have it down a little bit or farther down or different like that. So we're just going to preview what this is going to look like. I'm just going to move it all the way to the top, going to come down and select calculate. And we could see that the profile toolpath is starting at the top of the material and coming down to that 3/8 of an inch. So let's just do a quick preview. Should always reset the preview first. So I'm going to preview this or reset the preview, and so we can see that that is starting from the top and going down into the material. So by doing it this way and knowing that we had set that gap bottom to be 3/8 of an inch, and our profile is also 3/8 of an inch. So at this point right here, we should have, well, the 3/8 plus the offset that we have drawn here, this down section here. So let's go back into the toolpath that we had created there and just move this to the bottom. And now we could see it is no longer sitting at the top. It is down into the material quite a bit, all the way at the bottom. So if we reset the preview here and preview what this is going to look like, preview visible toolpaths, we can see that that is now recessed down into the material, the height or the location that we specified in that light brown area. So one of the reasons that you may want to have it, set at the top, because that's a lot of roughing that you'd have to do unless you're looking for the material or the molding to be the right material. So if we had this molding and we really wanted it to be 3/8 of an inch, and that is it, the molding that we have, we would have set it to all the way to the bottom. And at that point, I would create a rectangle to go around the whole object here and profile cut that out. So why don't I just go ahead and do that right now so we could see what is going to happen. And to help create that rectangle, I'm going to close the tool pathing here. To help create that rectangle at the right size and to help simulate what is really happening, we're going to just drag our profile over onto the line that it's extruding. So as we've seen, we don't have to have the profile shape anywhere close to the line that we are extruding it along. It could be off to the side, out into space. I typically like to have it close to the material and on the material to help line things up. And the reason why I'm doing that here now is just to get an idea of where this rectangle or the size of this rectangle should be. Selecting the profile, we see that we have a width of 1.4023. Well, that is a very odd size. So just to make things easier in my brain, I'm going to come over here to set the object size, and still having that unlinked, I'm going to make it a more rounded number of 1.4. Really didn't change the overall size, but it just makes that number a little bit easier for me to remember. And the reason why I did that is I want to draw out a rectangle to be the width of that 1.4. Go by 9. I'm going to move that up into the line a little bit to give us some space on the top and some space on the bottom. We could also do that by just selecting the rectangle, selecting the other line, using our line tool to center it there. I had that profile selected as well, but that's all right. So now what we have is we do have the profile toolpath, deleting the one that's going around the rectangle. We have our profiling toolpath, which is set here. And now if I want to cut that out, I'm going to use this rectangle right here to do a profile toolpath. The total depth is going to be 0.76 because my total material is 3/4 of an inch thick. Selecting an end mill. Of course, that is for aluminum. I don't want that. An end mill of 1/4. Set your number of passes and so on. Hopefully all are understanding on that now, but ask questions if you're seeing something that you have a question for. So right now there is the profile toolpath, and I tend to click through quickly on things. So just looking at it, it's not looking quite where I expected it, but our preview tells us everything about everything. So we're going to preview that visible toolpath, and well, that's not what I really expected. So let's see, what did I do wrong? So I'm going to go back into the profile toolpath, and I have the option checked to cut on the inside. We want to cut on the outside of this rectangle. Just coming down, clicking calculate, and I do get this warning that I'm going to cut all the way through. I always want to make sure that we remember to hit that decimal point there, making sure that we're not cutting 76 inches into our table. 10 thousandths is okay, so we'll say okay with that. I'm going to reset the preview and now preview all toolpaths. Double clicking out onto our waste is going to remove that to allow us to be able to see just the finished part. So now, by having that material or that model in the toolpath set to the bottom, what we have left here is exactly what we have drawn that profile to be. If we had set it to the top of the material, then we would have a lot more material down below here that may or may not be what you're looking for. So if you wanted this molding to be this size, as a you were going to take it to a miter saw to frame it up and make a a picture frame out of it, then you might want to have the material, this section here of the cross section, set to the bottom. But if we are going to create a a carved picture frame and then add some three-dimensional or some text to the center of it, you might want to set that to the top. So another reason that you might want to not have the top set to perfect 0 is if your material is not perfectly flat. So if we have material that has a little bit of a bow or some high spots to it, and we happen to zero Z0 or Z on a higher spot on that material, then when it is cutting through here, if this section in the middle of the material happened to be lower than over here, then the bit is not going to be taking any material off of there, and we'll see that flat spot. So by setting it down into the material just a little bit, that helps ensure that that bit is going to completely touch or completely get all of the profile that we have selected. All right, so that is like the toolpath position in the model. So we're going to change that back to the top. We're going to take a look at the bit selection now. So the bit selection for a molding toolpath is going to be very similar to what you would use for toolpathing a three-dimensional model. You really want to have to use the biggest bit possible that's still able to pick out the detail. So let's take a look at our 2D view and look at the actual cross section of what we have here to see what bit we might be able to use and still get the detail that we want. So a lot of people think that, I'm just going to move this off to the side, think that the smaller the bit, the smoother and the finish you're going to get. That's not really true. The smaller the diameter of the bit means that the more detail that you're going to pick out and is going to show. It doesn't have anything to do with the smoothness of the cut. It has to do with how much detail is going to pick out. So we're going to take a quick look at how to select, or how to possibly select, what bit might be best chosen for this product. So I'm just going to draw out a circle. And for doing this type of work, we really would use a ball nose. So this is why I'm selecting a circle to draw out a diameter of 0.25. Just looking to see what would happen if we used a 1/4 inch ball nose. I'm going to draw out one more that's half that to be 1/8 of an inch. And one more down, let's go to a 0.0625, which is a 1/16 of an inch. Just change the one that I had already drawn there, so 1/8 of an inch. Let's go. All right. So now let's just kind of using these circles to simulate what is going to happen. So this top section right here, there is no reason that an 1/8 of an inch bit or a 1/4 inch bit, or even at most a 1/2 of an inch diameter bit, would not be able to get around and do all of this detail here. I'm going to change my smart tapping or snapping. What that smart snapping was doing was allowing it to snap and hold horizontal, so I wasn't able to kind of rotate this around. So far, this top section, a 1/4 inch bit would do it. This swoop down here would do it. So from the section from this point to this point, that 1/4 inch cutter would make it work. From around here to here, that 1/4 inch cutter is going to work and make it just as smooth as if we used a 1/16 of a bit. But what it would not do is it would not be able to get into this section right here. So we could see that that 1/4 inch cutter would not pick out the detail that we have lost right here. Doesn't mean it's going to be any smoother or finish is going to be any better. It's just not going to be able to get us the detail that we're looking for. Let's drag that out of the way. Let's bring the 1/8 inch bit down. That's looking a little bit better. That still has some area that it's not going to get to. Might be okay with that, may not. If we really need to have that detail there, let's just drag and bring over a smaller 1/16 inch diameter bit. So that is 1/16 or smaller is going to definitely get us the detail that we want or may want to have. But if the smaller the bit, the longer it's going to take to carve. So let's just quickly go through and actually use the preview toolpathing here to see what this is going to look like. So the area that we were just looking at is this area right in here. I increased the quality of that preview, so we're going to be able to see the detail a little bit more. Just preview all the toolpaths. It does take a little bit longer to preview this than if it were higher, but the clarity of this shows up a little bit better. So that was with an 1/8 inch ball nose, I believe. So we're going to take a look at changing that to a 1/4 inch just to see what kind of detail is lost. Now, there's going to be a lot of roughness happening here. So we can see that the step over between all of this is quite big. So this is going to affect the quality of the surface, both detail and surface. I'm going to go back into that again and take a look at what I had set for the step over. Bringing that down to 10% is going to put those lines closer together. We will reset the preview, just making, kind of holding that in your memory of what that looked like, and do a preview all toolpaths. So we can see that that is not detailed as much as it was, but the surface finish is roughly about the same. We're seeing a little bit bigger scallops here, but we could always bring the step over in just a little bit more. Going back into our toolpath here and going to select a 16th inch ball nose. The same 10% step over. I'm going to calculate this out. So as we can see, we're able to get that detail brought out there. So some of you might be saying to yourself, like, well, no, I told you earlier that the bit diameter doesn't affect the surface finish. But you might be looking at this and saying, well, I'm wrong, because the surface finish of what we're seeing along here, we're not seeing all those big scallops that we saw with that 1/4 inch bit. So I used a consistent 10% step over, which means that the 16th, it's like scaled from the different size bits. So let's not do it by a percentage. Let's do it by a set number or the same number. So let's just quickly take a look at the bit number, the 16th inch ball nose, and I'm going to come in here and look at the value of the step over, which is 0.63. Now make note of how smooth this finish looks like. You know, we could zoom in here a little bit. We start to see those scallops there. But for the most part, we're pretty smooth, looking good. I'm going to change the cutter back up to the 1/4 inch ball nose. I'm not going to make any real changes other than putting that back to 10%. That 10% is the same as what we originally did with the 1/4 inch cutter. I'm doing this just so we could see how we are going to effectively get the same surface finish with the 1/4 inch bit as we did with the 16th, just not the detail. So calculating this out, reset the preview so we could see what this looks like. So we do see those ridges there, and that we did not see with the 16th inch bit. We could get rid of those by bringing up the toolpath here and changing it and not going by 10%. What if we use the same step over value, not as a percentage, but a value that we had for that 16th bit? So there we could see that the 1/4 inch ball nose will actually end up giving us a slightly better finish, or a better surface finish, than that 16th inch ball nose did. Yes, we are very tight on our step over, or our percentage of step over, but it is the same as if we used the 16th inch bit. And one reason why you might want to do what we just did there, rather than using that 16th inch bit with the tighter ball nose or tighter step over, is the 16th inch bit is it's very likely that you could break that bit, especially cutting this kind of depth. Or that 16th inch bit, if we use that, we would most certainly have to do a roughing pass to remove all of that material. But by using a 1/4 inch bit, yes, we're not getting the detail in that little bead section right there that we are with the 16th inch bit. we are getting cutting this with a stronger bit and also getting the same type of smoothness finish across the product. All right, so now we're going to take a look at a couple other settings that we have within here. I'm going to bring that back just quickly, just so we can see what's happening here. Bring that back up to a 10% step over, and going to recalculate what we have here. Just uncheck something. Don't worry about that uncheck just yet. So we're going to see what this looks like differently. So reset this preview, preview it once more. So a lot of times with the toolpath, and we can see we're smoother here, kind of a little bit rougher across the top, and that's just the way the geometry and the shape is kind of matching as it falls off the edge. And we are very consistent on the step over that we have. It's not a step over based on the surface area that it's cutting. It's just looking straight down, stepping over the consistent depth of 10%, which was at going to be 0.025. To get maybe a little bit more detail and a little bit smoother cuts in some areas where it's needed, we are able to vary the step over. Coming back into the toolpath, we're going to vary the step over. Coming back down to calculate. Not too many more toolpaths that showed up there line, so let's try it and see what happens with a smaller diameter bit. So right now the variable step over was set. So what we have, and we'll run it again without it. So you can see we're fairly consistent through here. We have a little bit tighter toolpath here, and you can see right here, it's not a consistent step over. So that's going to kind of give us a little bit smoother cut in this area here. So double clicking here, and I'm going to deselect the very step over, select calculate. So you can see how that kind of opened that up a little bit and brought it back to a consistent width of stepping over. Going back to the 2D view, bringing back up. Now I talked about roughing. So if we did have this material drop down into the material, that is going to be the case where we might have to rough the material out, even a 1/4 inch bit. If this was hardwood, that 1/4 inch bit may even have a hard time getting down to that area in a single pass, because it's really exactly what's happening, is making all of this in a single pass. In the toolpath, we have the option to use a larger area clearance tool for the kind of the roughing. So that's 1/8 inch bit selected here, which would most likely break cutting this into hardwood. So let's just say we have to use a roughing pass. At this point, it's just a roughing pass, I might use an end mill to upcut end mill to kind of quickly and more easily get rid of that material. I'm going to reduce the step over here. I'm not going to go down to 10%. I'm going to go down to 20 since this is just a roughing pass. And I'm going to add a machining allowance to this of a 1/16 of an inch roughly. And what this machining allowance is doing is, what it is saying is, with this 1/4 inch cutter, do not come within a 1/16 of an inch of our selected profiled shape. So we will be able to see both of that in our profile here. So there is the roughing toolpath, and that 1/16 of an inch is the difference from the height here to here, and same thing over here. We're making 2 layers of roughing here at the top, 1, 2, 3. The number of layers that it is creating is based on the pass depth of the cutter. And notice that we also have 2 profile cutters here. Now, one is the clearance, the roughing pass, and the other is the finishing. So double clicking either one of these is going to bring up the same parameters for both of them because they're still a linked toolpath. For the roughing toolpath, let's change that, and let's increase the pass depth or decrease it because I want to kind of ease its way down into the material, and I want to be able to just clear out more material first. And we can see just by doing that, added 2 more passes, and also getting into this area over here. For those that joined us a couple weeks ago or last week, or it could even have been this past Tuesday, we were talking about Z-level roughing. So basically this is what is happening here. It's kind of a Z-level roughing, our area clearance of this profile. So let's run this preview. We'll do it in steps. We'll first do the area clearance. So I will preview the visible tool passes so we can see what it looks like. All right, so that is the kind of the roughing toolpath. See it step down into the smaller spots, and then there is the finishing toolpath. I'll just do a preview of that. And then to cut it out, we would just simply run that final pass. So that is kind of all about straight line profiling toolpath. We're going to take a look quickly at how we could create a picture frame out of this. And again, just coming back out, move this off to the side. Not that we really have to, but just that I want to. And I'm going to delete all of the toolpaths that we have in the list here to start kind of fresh and over. Don't need our circles there anymore. So now if we wanted to take this profile and extrude it around the outside of here, we kind of saw that earlier. So I'm going to select the square. Then the last selected object is what we're using as the profile for what we have here. And again, the high side is going to be against here. If this is like a picture frame or a frame that we're carving out to maybe put a 3D model or something in the middle of this, I'm going to right click and reverse the direction of that and set the material up to leave 3/8 of an inch on the bottom. Calculate that, reset this preview, and preview all the toolpaths. All right, so that is the basic shape and the profile that we have selected. It comes around and comes down into there. So now if I wanted to create a a frame that we're going to put some text or V-carving or a 3D model or an image in the center here, this area here, we really should kind of remove that out of, do an area clearance or a profiling toolpath or a pocketing toolpath. around the outside, or really the inside of this, because again, I'm just going to drag this over to show what we have. This profile is sitting right along that line right there. So with that sitting there, we could select our rectangle, profile, or drive rail and do a pocketing toolpath. Now, how deep should we make this? Well, we know that our total profile thickness is 3/8 of an inch. So from the highest point, which is at our surface, down to the lowest portion here is 3/8 of an inch. So let's cut that depth down to 0.375. And do area clearance with the 1/4 inch cutter. And just for speed's sake, I'm going to change our quality back up to standard and preview all the toolpaths. So that is removed out. Now, you might be saying, well, wait, why is this extra step here? Well, that extra step is coming from not here, that is the bottom side of this profile right there. So that is where the bit in the profiling toolpath, and that's where the 3/8 is coming from. So even though the toolpath for the profile is not coming out any farther here. So if we did want to have our pocketing toolpath not have this gap here, we just wanted it to flow straight out along at the same level as this line here, we could do that. We have a handy dandy measuring tool over here for measuring there. So I'm going to select and get the dimension from this top point to the high point here. Now, even though it's on an angle here, I'm not looking for the total distance. I'm looking for the distance in the Y. So the Y distance is 3026. So changing the pocket depth to 0.3026, recalculating, do a reset and a preview all, and there it is. It just kind of flows straight on out, and you do see this extra gap step down here, but this step down is not at the end. It is not at this line. This step down here is this profile right there. So now what this allows us to do is we have a flat spot area to create a carving or text or whatever we want in the center of this. So let me just finish this out by cutting this out so we can get a better idea of what we have here. With that rectangle selected, I'm going to offset outwards by 1.4. 1.4 is because I think that was what the width of that profile that we created. Offset that and use this offsetted vector to profile cut on the outside all the way through the material. Let's do a preview of the visible toolpath. So now at this point, we're able to add whatever we would like in the center of this. If we wanted to use our clip art, I'm just going to scroll down through here to see the best type to use would probably be a one that is dished out, which I don't know if I have any that are already pre-downloaded. It's always hard selecting, trying to choose what you actually want. Let's throw a deer in there. So we do have to log in. It's the best thing about, I think they've gone to the portal here to allow us to be able to not always store our clip art on our computer. So it allows us to be able to log in. You know, somebody's just getting logged in. Oh, I have to accept the accepted. So it's been accepted. This time it should allow me to continue, and it is. Good. So now it's going to download. I'm going to drag and drop that over into our model. And to fit it down inside, just going to shrink that down simply just by eye. Now we're going to learn a little bit about 3D toolpathing here and see what might go wrong. So again, if I want to do a 3D preview or toolpath on the deer, just coming in, selecting. So you may have seen what just happened there, but I'm going to take it a little bit slower and we'll see what happens. Come back into this because a lot just happened there. So I'm going to do it on the model boundary. It's got the 1/8 inch bit, so we'll see, okay. So selecting resetting the preview, and we have our 3D finishing toolpath here of the deer, and I am going to only preview that toolpath there, which looks okay. Let's do a preview of our profile. Still kind of looking okay, but now what's going to happen when we do our pocketing, that gets wiped out. So we have for the 3D, the same type of effect that we have with the sorry, the toolpath of where that model is going to be set within the job. So this is the model. And come up here and click select. This grayscale, or the grayer or lighter brown, is how and where the model is sitting within the material. So what we want is going to have a gap above the material. If I remember correctly, we pocketed out 0.3026. So from the top to the top of our model is where we're going to set that in place, and we'll say okay to that. And once you change that, it says that toolpaths have to be recalculated. Let's preview all of these toolpaths in the same way we did. It's not how I would cut it for real. We're just going to preview them this way. So with this one selected, preview the toolpath, and we can see this time it's sunk down into the material. That's good. So let's preview rest of it and see if my memory hit that height just right, and we are. So that kind of shows how to pocket out the material at the depth that matches up to the profile, and then also how to bring in a 3D image and set in on top of that. One more thing that we will just point out is take a look if we weren't working with a 3D model and being able to recess it down into there. What if we had a shape that we wanted to cut into the surface? It could be V-carving, text, whatever the two-dimensional shape is. We would not be able to just simply V-carve that from the top down. because we really have the same exact thing that happens. I'm going to reset the preview and preview all that happens there. And oh, how'd that happen? I was not expecting that star to be cut where it was. So let's see why it did. I must have the projection to 3D model selected. So two ways of doing that. One is I projected it to the 3D model, which was to the preview that we had already removed. It's not necessarily the way I would do it since this area is flat. I'm going to uncheck the projection there and come up to the top and use the start point, so the start depth. So we're going to start from the top down at the 0.3026. So essentially projecting to the 3D model or using that start depth essentially gave us the same thing, but the difference is the projection to 3D is when you're trying to project a shape onto a contoured type 3D surface. I wouldn't necessarily use it for projecting onto a surface that is already cleared out flat. So that is, that's a lot of information there on the toolpathing. I was going to talk a little bit about how to stack up a form tool. Got a few more minutes. Hopefully we're not overloading our minds. So what we have now is, if we wanted to create a much faster toolpathing, rather than doing this 3D type profile extruded, which could take some time to cut around here, we might have cutters or bits that are designed for doing profiled cutting. So I've drawn two of them out. So you could buy cutters that have this type of a profile. So you would just use a profile cut either on the line or however you want to do it for this here. So the way I typically would do this is use the drawing of the bit and line it up on the material, assuming that this is my 3/4 inch high material, and looking to see where on that material I would want to have this profile type of shape. So if I wanted to put an edge on the material or a doubled up edge, I could sit there and do math and figure it all out. But why do that when we have the measuring tool? And we could just simply lay this out and just do a duplicate of that to be able to maybe stack it up to get a double shape out of this. So what this is going to do is show us how to use a rectangle like this one here to be able to profile cut an edge that is going to have this double bead on it. And to do that, I'm just going to use the profile toolpath with that vector selected. For the first one here, from this one here is the top side, we're going to do on the inside, and getting a dimension tool from the midpoint to the end point and making note of that distance, 4213. That is the distance that we want to offset to the inside. So I'm going to select the bit, come down to my form tool selections. The cut depth is going to be the depth from the bottom to the top. So again, just using the measuring tool, selecting from here to here, which now is the 5315, so 5315. I'm not going to make any other changes here, just so we see what's going to happen. Calculate. Why does it not know what I want to cut? There we go. reset all of the previews and just do a quick preview of what we have right there. So. And that offset completely to the outside. And that is putting the edge of this bit to the outside, where we really want to have the distance from to be able to create an offset here. So if we want it to be offset to the inside, and then you would use an allowance for this gap here of maybe 1/8 of an inch in cutting. So a little confusing on maybe how to set the offsets there correctly, but just typically with form tools, that's how I kind of stack them up and then use the measuring tool to measure heights and depths and get into that. Maybe that could be a whole separate topic. I apologize that we didn't get in depth and wasn't real set on that. So we'll spend more time on that at another date. So yeah, you could certainly use a V-bit to get into some of those areas. Let's take a look at what we might even want to do for that. So I'm going to delete that toolpath right there. Yes. So one of the reasons that it is nice to maybe put the bit exactly on that profile there is to know where that V-bit might go. So we could offset this line outwards from here to that point right there. So that offset distance is 833. We could offset that outwards by 0.833, and it was 4 3s. I wish I had a better memory. So what we would do, again, just using the measuring tool, measure that distance from there to there to know how far, so I'm off a little bit, to know how far off to offset a line. And what we could do is just use the V-bit to profile directly on that line at a depth of whatever that depth is. So creating a line from there to there, cutting in the Y, cutting down of almost 1/8 of an inch right there, and just do a profile on the line. Yeah, so that what I showed for that V-bit, yeah, absolutely, same process for creating a maybe a sharper corner here. And to speed things up, you may want to think about the profiled shape as well, is not even have this section be using. So you might trim away some of the profiled shape to not include this flat section, because even though it's not that big around there, there is several passes that a 1/8 inch bit is going to make that flat. So you know, why not take this line, offset it out here, and extrude the profile from here to here around, and then just use a 1/4 inch flat bottom or end mill to profile or cut around the. All right, well, thank you again for joining.